We have this exercise and need to solve it together. This exercise considered as an application about finding the derivatives of a functions and how can we use it to solve any problem. So please let us thinking together. We have here the function with a domain mentioned here. Said the rule of the function is, as you see, and the domain is the interval, the closed interval from minus pi to plus pi. We need to find all the points, as the exercise said. We need to find all the points on the graph of this function where the tangent line is horizontal. And after then, we need to draw a roughly diagram for the graph of the function. Let us start together now with this condition. This condition said the tangent line is horizontal. We know the slope of the horizontal line is equal to 0. And the relation between the slope of the tangent and the function is the derivative of this function equal the slope of the tangent. So the derivative, which can be referred by f dash x, is equal to, here 2 is constant multiplied by variable, so it will stay on the answer. Find the derivative for sine x. We know the derivative of sine is cosine, so we write cosine x as derivative. And for sine square x, here as chain rule, which we mentioned last video, we start with the power, take it in the front, so we write here 2 sine, and now the power decreased by 1, so 2 minus 1, that's mean 1, so we after then multiplied by the derivative of sine itself, which is cosine x. So this is the derivative of the function. You see here we have common factor, which is cosine, and 2 also. We can take this as common, and of course, as we will put the function derivative is equal to 0 as the tangent is horizontal, so we can divide on 2 to eliminate the 2, the constant. So we will do it like this. As the tangent is horizontal, so its slope will be equal to 0, is equal to 0. Then we can write 2 cosine x plus 2 sine sine x multiplied by cosine x also is equal to 0. We can divide both sides on 2 to eliminate the constant. So we will get cosine x plus sine x cosine x equal to 0. So we'll take cosine as common. Then here will stay just 1, and the second term will stay the sine x. All equal to 0. Now we have equation. We need to solve the equation to find the value of x. Here, two factors. This factor, we put it equal to 0. And this factor, we will put it equal to 0. So as we got two equations then. First one is cosine is equal to 0. And second one is 1 plus sine x is equal to 0. Let us look together what's the solution for these two equations. We have in this graph, the red color shows the graph of sine in the interval, which is the domain of the function, in the interval from negative pi to plus pi. This, the red color, refer to the sine x graph, and the green color refers to the cosine graph. When we study each one of those two graphs, we find cosine will be 0 here. Cosine is 0, which is the point of intersection with x-axis. And here also 0. This value give me the angle is pi over 2. And this give me, the first one is pi over 2, and the second one is minus pi over 2. Now when we look in the red graph, which is referring to the sine x, we find, but we don't need to study only sine x, but we need to study 1 plus sine x. The equation here said 1 plus sine x is equal 0. So this will lead me to value of sine x by moving 1 here to the other side. It will be negative. So this will give me sine x is equal negative 1. Then we will just look here when it will be negative. When the sine x will be negative 1. Here is negative 1. This should be referred to negative 1 when x is pi over 2. If we got a correct measurement, this will be 1 when x is minus pi over 2. So just this graph to explain how we can find the solution of the two equations we got. So we can write here for the first equation, x equal minus over 2 and plus pi over 2. For this equation, we said by moving 1 to the other side, it will be sine x is equal minus 1. And we also have one answer. X is equal minus pi over 2. To get a look again on the question said find all points on the graph of the function, this function, during this period with this condition. We found already the values of x, so we need to find the values of y for each point. As you see here, the answers we got, just we have 2 points, because this value for x in this equation, it's the same value here. So this is coincide together. And this one also, the second one. So we just have 2 values for x. So we'll make substitution by each value and the rule of the function. We said when x is equal to minus pi over 2, so if minus pi over 2 will be, by make substitution about x and the rule of the function, 2 sine x, that means 2 sine minus pi over 2 plus sine square minus pi over 2. And we try to find the value. The value we will get, it's the y value. This the x value, and the value here is the y correspond to the x value here. By this way, we got the first point. Let us calculate the value here. We did see in the sine graph, sine minus pi over 2, -1. This value is -1. So this -1 again, but here we have square. So -1 square. And don't forget the 2 is here. The value will be 2 times -1, that's mean -2. And here plus 1. Because -1 squared, that's mean +1. So the value is -1. Then the point is, the first point I mean, we found x is minus pi over 2, y is -1. This is the first point. We can write minus pi over 2, and -1 is the point on the graph where the tangent is horizontal. Let us look for the another answer. The another answer when x is equal plus pi over 2. So if plus pi over 2 equals 2 sine plus pi over 2 plus sine square plus pi over 2. And we also try to find the answer for this. Sine pi over 2 will give me +1 here. So the answer is 2 times +1, that's mean 2. And here also +1, so +1 squared, that's mean 1. Then the answer will be 2 plus 1 is equal to 3. So the point is x by over 2 and y is 3. So this is the second point, which is y over 2 for x and 3 for y. Then we have 2 points here where the tangent is horizontal. So this point and this point. By this way, we finished the algebraic solution. They just asking me to draw a roughly diagram for the graph of the function. I will try to draw roughly the graph of the function. I already drew the tangent horizontal here, which passed by the first point we found in our solution. Here we solved and got 2 points where the horizontal tangent are. So this is the point negative by over 2 and minus 1. And this point also, which is by over 2 and 3. Both are horizontal. So the graph will be here and here. You see, just here tangent and here tangent for the graph. And it will go like this way. And we can extend the graph till the end of the domain is from negative pi till plus pi. So we can draw it till here until here. So this is the graph. Roughly, it is the graph they wanted me to draw for the function. And if you want to make it more precisely, you can choose more points for x and find the corresponding points for y, and then determine them, then connect them together by line. And I will try to give you more questions in the next or in the coming videos. Thank you for watching and see you again. Bye bye now.